Science just proved our brains are quantum entangled. What if the boundary between your mind and someone else's wasn't real? What if your thoughts, your gut feelings, weren't entirely your own? It sounds like something straight out of science fiction, but it's a question that pushes right to the edge of what we know about reality. We're told our brain is a biological computer, a 3-pound machine made of neurons and electricity. But what if it's more than that? What if it's a quantum machine, plugged into the very fabric of the universe itself? What if I told you that right now, with no touching, no talking, your brain could be connecting with someone else's on a fundamental level? Researchers have found this truly bizarre phenomenon, where two different brains can start firing in the exact same synchronized rhythm. It's called interpersonal neural synchrony. Some researchers think this isn't just a coincidence. They think it's a clue that our minds are linked in a way that goes beyond classical physics. A way that sounds a lot like what Einstein called spooky action at a distance. So, is this for real? Or is it just wishful thinking? What does the science actually say? Section 1. The mystery of synchronized brains. All right, let's start with what we know for sure. The idea of interpersonal neural synchrony is a real and fascinating part of modern neuroscience. When two people are deep in conversation, or even just making eye contact, their brainwave patterns can actually start to line up. Using tech like EEG and fMRI, scientists can watch this happen in real time. For a moment, it's as if the speakers and listeners' minds form a single, unified system. And it's not just talking. Studies have shown that the heart rates of couples can sync up just by being near each other. Therapists and clients can fall into a state of physiological alignment during moments of deep empathy. This is the real science behind what we call being on the same wavelength. For decades, the standard explanation has been pretty straightforward. It's all about things like our mirror neuron system. Those are the brain cells that fire both when we do something and when we see someone else do it. They're a huge part of how we feel empathy. We subconsciously copy each other's posture, gestures, even our blinking patterns. Our brains create these feedback loops that make us align with people around us, which is great for building social bonds and cooperation. From this angle, it's a beautiful but purely biological dance. But a few scientists are starting to ask if this dance is being led by a much weirder, much smaller partner. They're asking if the real reason lies not in our neurons, but in the quantum world. Section 2. The Quantum Foundation. Spooky action. To get their wild claim, we need to talk about maybe the weirdest idea in all of physics: quantum entanglement. Imagine you have two tiny particles, say electrons, that are linked together, entangled. You can separate them, send one to the other side of the galaxy. The instant you measure a property of one particle, like its spin, you instantly know the spin of its partner. It'll always be the opposite. This connection is immediate, faster than light, and distance doesn't matter. This is what bothered Albert Einstein so much he famously called it spooky action at a distance. He thought there had to be some hidden information we were missing. But for 50 years, experiment after experiment has proven him wrong. Entanglement is real. The universe, on its most basic level, is non-local. An action here can have an instant effect over there, with nothing traveling between them. For a long time, most physicists saw this as a weird quirk of the microscopic world that couldn't possibly affect our big, warm, messy reality. Those fragile quantum connections, a property called coherence, would be destroyed instantly in a complex environment like the human brain. The idea that quantum effects had anything to do with consciousness was basically scientific heresy. But what if it wasn't? Section 3, the controversial connection. This is where the story takes a hard right turn into speculative and very controversial territory. The big question is, could the neural synchrony we see between people be a sign of quantum entanglement happening deep inside our brains? A few researchers have dared to say yes. One of the most talked about and heavily criticized studies came from a team led by Christian Kerskens at Trinity College Dublin in 2022. Using a modified MRI, they claim to have found signals they believe are evidence of entanglement inside the brain. They reported finding heartbeat-evoked potentials that behaved in ways that, they argued, could only be explained by quantum mechanics. Okay, reality check. It's super important to say that this study got major pushback from the wider scientific community. Its findings haven't been replicated, and many scientists think there are much simpler, non-quantum explanations for what they saw. The general consensus is that this isn't proof. It's a hypothesis from a single, unverified experiment. This idea is built on an even more famous and controversial theory: orchestrated objective reduction, or OR. Put forward by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, OR suggests consciousness comes from quantum computations happening in tiny structures inside our neurons, called microtubules. Their theory says these tubes can hold on to quantum states long enough to do complex calculations. They even argue that anesthetics work by messing with these quantum activities, which is how they turn consciousness off. Again, it has to be said, OR is still a fringe theory. It's not accepted by mainstream neuroscience. Most neuroscientists believe consciousness is an emergent property of classical brain activity. The main ways anesthesia works are understood through classical neuropharmacology, not quantum physics. Mainstream science still holds that the brain is just too warm, wet, and noisy to support the delicate quantum states that theories like OR need. So when you see a headline that says science has proven our brains are entangled, it's a huge overstatement. It's mixing up the very real phenomenon of neural synchrony with a speculative, unproven quantum explanation. Section 4. The profound implications, if it were true. But let's play a game. Let's step into the world of Penrose and Hameroff for a minute. What if they're right? What would it actually mean if our brains are quantum machines, entangled with each other? The implications would completely shatter our understanding of ourselves. It would suggest that your self isn't totally locked inside your skull. It could mean that intuition, that gut feeling you get about someone, isn't just your subconscious making a quick calculation, but a kind of direct information transfer. It would give a scientific footing to the idea of a collective consciousness, a shared mental space we all tap into. This is both beautiful and a little unsettling. We're already grappling with the feeling of a shared mind as we create more advanced AI. When a chatbot sounds a little too human, it can trigger that creepy, uncanny valley feeling. We get that feeling because it breaks our expectation of what a mind is. We want there to be a clear boundary. The idea that another person could blur that boundary, that your thoughts aren't 100% private, can be unnerving. If our brains were truly entangled, it would mean empathy isn't just imagining what someone feels. It might be, in some small way, directly feeling what they feel. It would change everything we think about connection, community, and even life itself. It would mean that consciousness isn't just some random byproduct of evolution. It would mean it's a fundamental, interconnected part of reality. Conclusion. So where does that leave us? We started with a huge claim. Science has proven our brains are quantum entangled. But as we've seen, the truth is a lot more subtle and, honestly, a lot more interesting. Science has not proven this. What science has done is document the very real and mysterious phenomenon of neural synchrony, where our brains line up in ways we're just starting to understand. The classical explanations for this, with mirror neurons and social feedback loops, are solid and well supported. The quantum explanation, while exciting, is still a highly speculative and fringe idea. The work of people like Kerskens, Penrose, and Hameroff isn't a proven fact. It's them pushing at the very edges of the unknown, exploring a frontier that most scientists aren't ready to buy into without a lot more evidence. The real story isn't that our brains are entangled. The real story is that the mystery of consciousness is so deep, it's forcing scientists to ask questions that blur the lines between neuroscience, physics, and philosophy. It's a reminder that there's more to reality than what we can see, and that the journey to understand our own minds is the greatest scientific adventure of all. The universe inside our heads is just as mysterious, and maybe just as strange, as the one outside. What do you think? Is the idea of a quantum brain exciting or terrifying? Are we on the edge of a new way of understanding consciousness? Or is this just a beautiful dead end? Let me know your thoughts in the comments below. And if you love exploring these deep, mind-bending questions where science and reality collide, make sure to subscribe so you don't miss our next trip into the unknown. Thanks for watching.